Well, making videos is really tough sometimes. I lost about an hour's worth of video, maybe more, when the focus on my camera was wrong. It turned out to be 10 inches in front of the lens instead of out here. So what I've done now is I'm just taking a tape measure, measuring how far from the lens and adjusting the lens on the distance instead of depending on the autofocus function. So this video is going to be a little disjointed because a lot of this work's already done and I showed how to do it in the autofocus video. So I don't know how it's going to actually come out. I'll just go over what I've done and then skip back to some of the video that I did after that. That's okay. To start with, well, the whole project is I have this Paragon oven, and it just had well, I'll show you. It had this. So it's got a on-off and temperature switch, 1 through high, whatever that means, and a analog temperature gauge. So I talked to Bar Z, Stan down there, and I've always wanted to convert this, so I collected all the parts and pieces, but I didn't really have an elegant way of mounting them. I think now I could have put them all on that front piece, got it all to fit, but I like the setup he had. So what I did is I talked to him and he sent me just the sheet metal enclosure. That's it, nothing else. All the pieces that you see are parts and pieces that I had scrounged, except, I'll back that up, he sent this limit switch that came with the sheet metal enclosure and this pin. I made these two items here. Okay, alright, moving on here. So I cut out some pieces of stainless. This stuff's pretty thick. 57 thousandths thick. I have no idea what gauge is. In the aircraft A&P world, we only deal with actual thickness of metal. We never deal with gauges, it seems. At least I haven't. So this is going to be a bracket at the front that the pin, what's it called, the interlock goes for the door. So I'm going to use my favorite marking technique, which is just this marker, no dicum. I'm not cutting on it. I don't care if it washes away. I just need a line here, temporary, quick and dirty, halfway down. One thing you can do, if you're not sure the exact, you don't want to do the math, just get it close and do 2 lines, and then you know in between it is center. This doesn't matter. So what all I'm going to do is put this in here. This is my finger break, so to speak. I'm going to leave it a little bit for the bend radius and make it flat here. That's not too bad. That's for what I need. Well, that's actually pretty good. So that'll go over here. I think I'm going to put it like that, and then I'll drill a hole through this, and that's what the pin will ride on. Or you can go like that. Now I need to bend a bracket here to come out and hold the pin the other way. So that's pretty good. That should work. worked fine. Here I've just got a Cleco in holding after I drilled the first hole. I'm using it to steady it to drill the second hole. So next, I'm going to take this blind rivet installation tool. Some people call these pop rivets, but technically they're called blind rivets. Got a pneumatic one of these at the airport that I use. It's much easier than this. A quick rule of thumb that I have for mounting stuff, drilling holes, is I like to, like on this bracket here, I want to get it halfway in this distance. So I see how thick it is there. It's about 7.7, so 35. So I would take 35 and lock that in here, mark a line, and then for the other, I'm going to put 2 in here. So I like to divide this into fourths. It's 175 divided by 4 is about 45.15, something like that. So I'll just go 45. So I'll go back down to 45 on my calipers, mark it there, mark it there. So I'm a quarter in that way, quarter in that way, half the distance between them. That seems to work pretty good on just generally mounting things. It's what I've always used as an electrician with not having any further guidance. So I'll drill these 2 and I'll put it right there. Here's something else I like about that marking fluid. Just take a little alcohol. That stuff cleans up really quick. It's not like Dykem. It just smears over everywhere. Okay, mounted the control box. It all works fine now. So the limit switch is in. I have this temporarily mounted with some sheet metal screws. And now I have to figure out how I'm going to come out of here into here and get the wiring from the perimeter, the thermocouple wires, and the power cord up into here. So I'll see what I have lying around, my electrical stuff, and go from there. I'm thinking like an LB or something like that. Over the years I've amassed a bunch of junk. So what I had here is the back of a power supply I took apart. So I'm going to throw that part away and use the grill and the fan and mount them inside here like that, and that'll take care of the cooling fan that goes in there. I'm at this point, I've completed this interlock and that works fine. I've mounted my SSR, stands for solid state relay. Got my interlock switch. I've got my thermostat. I went ahead and mounted my fan inside the cabinet. I think it gives it a nice streamlined aerodynamic look. You know, like it's capable of 200 knots. That type of thing. Doesn't interfere with anything. And then what I got to do next, pick up a LB to get me down in here. And I've got inline fuse. So my idea now is this is called an LB, meaning it's an L shape and it comes out the back. It's an electrical fitting. This is a 3/4. So it goes under here. So I need to drill a hole through here and up into here. And since there's already a hole here, what I'm going to do is use this hole to a starter and then punch this out and then go in there. Because if I go and move it anywhere else, I end up with half a hole. And I don't want to. Okay, so there's already a hole here. What I'm hoping to do is take this thing, which is called a knockout punch, and move that hole over a little bit if I can. So when I put this, so what I'm going to first do is knock it out to 1/2 inch. Okay. Now I have a hydraulic pump, and this is going to be a little strange getting it started. I need to hold it off to the side. Okay, there we go, it's biting. Now, I gotta be careful because as this comes through, it'll just drop out and break some toes. Okay, now I'm gonna pull a 3/4 inch, which will match the LB. And I was able to move the hole over and that way a little bit with the 1/2 inch. There's a little bit of play in there with the drawbar, so that'll allow me to move it forward and move it over. I think that looks pretty good. First time I ever saw these used, I was amazed that you can just pull something through metal like that. So this is called a chase nipple, and the idea is to put that in there. I go like that, and then I'm going to drill a hole into the bottom there out the other end. What I like to do if I'm using a hole saw to drill a hole is drill it with the pilot bit first only, because when you break through, sometimes it's hard to stop that saw from going in, and then it jams this and you can bend the pilot. So now that I've already drilled the pilot hole, I just go in here with the hole saw. Just like that, one hole. Okay, now I just have to wire all this up. Okay, another word about wiring. When you're crimping on these connectors, like I'll need them for the fan and stuff, you want to use a pair of ratcheting crimpers. They have a dot on them telling you what it corresponds with the size of connector, so yellow goes yellow over here. Don't ever use this style. These are junk. I don't know where I even got this, but they don't work for cutting stripping wires. They don't work very good for cutting bolts. They're garbage. I had a job one time and guys were using these, or Stacon pliers they're called. 25% of the crimps failed because they weren't using the proper crimper. I also call these, besides ratcheting, I call them go, no go. So once you start ratcheting, you can't release it until you go all the way. And that makes sure that every time you get 100% crimp. So definitely get yourself a pair of these. These happen to be Greenlee, but you can buy some off-brands for $40, I think. And you can get them with all different types of jaws. Jaws for these, jaws for B and C connectors, for just about anything you want, anything that needs a crimp. So, highly recommend it if you're going to be crimping wires or connectors on wires, get yourself a pair like this. Hopefully this isn't focused enough. So I completed the oven, and I've got this controller, which is just real basic. Right now I have it set at 300 down here. This is the actual temperature in the oven. You can see the this little light coming on and off is when the element's coming on, so it's pulsing it. Now this controller it's like I said, it's real basic. When you turn it on, it starts the output for whatever you've set in here. Like I said, it's set it for 300. You can set it for any temperature, and it ramps up to that temperature. There's a whole bunch of settings you can do in there for the PID loop. And if you don't know what a PID loop is, go to Wikipedia and look at PID loops. But it has an auto function where you hit two buttons when you turn it on, and as it ramps up, it records how fast you're getting to the temperature, and it changes the value of the PID loop each time so that it doesn't overshoot. This one, the first time it overshot by like 50 degrees, but we're only going for 300. And then the next time it was overshot by 12, and the next time it overshot by 6. So it learns the PID settings itself. I decided I'm going to go ahead and get the one that Stan has in his, the Novus Control, because that one you can tell it how fast you want to ramp up and how long you want it to hold at that temperature. This is, it's all manual. You have to record your stopwatch when it gets up to temperature. You have to, record how long you're at temperature, all that stuff. It's strictly manual. But as a controller, it works. I think I only paid like $45 for this controller and the SSR in there. So, I'm not worried about that part of it. The new one, the Novus controller, is $115 with tax and shipping. So, anyway, it works. If I open the door, you can see the light starts flashing. So it turns off. Close the door. Now this is interesting on this oven. When it gets a lot of power initially, the coils vibrate. And then once they're on for a little bit, they don't vibrate as much. So, it was a good project. I'm glad I did it. I'm looking forward to doing some heat treating and actually to try and do some hard turning after that. Hopefully I'll have some future videos.